Okay, so here are our notes for section 7.4. And in this section, we are going to learn about using the z-test for our population proportion. Okay, so just like previously, we do need to check that n times p and n times q are both greater than or equal to 5. The test statistic in this case is going to be the sample proportion, which we represent with our p hat. And to find the z-score that goes with that, we're going to use the following formula. P hat minus p divided by the square root of p times q divided by n. Okay, so let's run through some steps. So the first step is you're going to verify that you can actually do this by checking to make sure that n times p and n times q are both greater than or equal to 5. You're going to state your claim and then identify which one is the H naught and which one is the alternative hypothesis. Specify what level of significance we're using for this. Determine your critical values. You can use table 5 in the back of the book, or you can also use your calculator. And then we're going to figure out where our rejection region is. And then we're going to find the z-score. Then we are going to make a decision to reject or fail to reject. And then we're going to write our summarizing sentence as our last step. Okay, so let's go ahead and knock this out with an example. Okay, so a research center is claiming that less than 50% of US adults have accessed the internet over a wireless network with a laptop computer. Okay, so the first thing I'm going to do is I'm going to write my claim down. Okay, so the claim is that less than 50%, so P is less than 0.5. All right, the complementary statement to that is P is going to be greater than or equal to 0.5. All right, so my H naught in this case is P is greater than or equal to 0.5, and my alternative, my claim, is less than 0.5. Okay, so the first thing I'm going to do is I'm going to check that n times p and n times q are greater than or equal to 5. Okay, so in this case, let's write down all of the information I have to just organize myself. We have P is 0.5, which means Q, in this case, is also going to be 0.5. Because remember, we're going to do 1 minus whatever the value is to get the complement, to get Q. In this case, N is 100. So we have a random sample of 100 adults. 39% say they have accessed the internet over a wireless laptop computer. Okay, so that's telling me my P hat is going to be 0.39. And in this case, my alpha level is 0.01. Okay. So now that I've written all of that down, let's go ahead and perform the check. So we're going to be doing n times p, which is 100 times 0.5, which is 50. And in this case, n times q is going to give me the same thing. It doesn't always happen that way, that they're exactly the same. But 100 times 0.5 is also going to be 50. So this is good. Yay. Okay. So then the other thing that I want to draw your attention to is the fact that this is a left-tailed test. Okay, so how do I know that this is a left-tailed test? I look at my null hypothesis, and since I have a greater than or equal to, that is a left-tailed test. Okay, So the z-score that corresponds to an alpha level of 0.01 for a left-tailed test is going to be -2.33. Okay, so what is that telling me? That's telling me that we get a little bit more room. Okay, there we go. That is telling me that if I have my bell curve like this, here is that z-score of -2.33. Anything to the left of that, so anything smaller than that, is going to be in my rejection region. Okay, so now let's go ahead and find the z-score. So I'm going to do z equals p hat minus p divided by square root of n times q divided by n. No, p times q, p times q. I haven't had all of my coffee yet. I have had like one sip, so I'm a little off my mat game. Okay, so let's plug in. We're getting 0.39 minus 0.5 all divided by square root of 0.5 times 0.5 divided by 100. Okay, all right, and if I do that, I'm going to get -2.2. Okay, so if I put that on here, -2.2 is here. Okay, so is that in the rejection region? No, so we are going to fail to reject this. Okay, all right, so we're going to write our summarizing sentence. Let me give myself a little bit more room to write that. I'm going to type it because otherwise we're going to be here for a while. Nothing like that first cup of coffee in the morning. All right, so let me change the font to something a little less swirly. Here we go. All right, at the 1% significance level, there is insufficient evidence to support the claim that less than 50% of US adults have accessed the internet over a wireless network with a laptop computer. All right, so that one's done. Yay! Okay, let's do another one. Okay, so for this one, we have a research center is claiming that more than 25% of US adults have used a cellular phone to access the internet. Okay, so let's go ahead and write down our claim. So our claim is that more than 25%, okay? So this is going to give me a p-value of greater than 0.25. So the complement to that is going to be P is less than or equal to 0.25. Okay, so my null hypothesis is less than or equal to. My alternative is greater than. So in this case, I know that this is going to be a right tail test based on my null hypothesis. And since we are at the 5% confidence level or significance level for my alpha, that is going to give me a z-score of 1.645. Okay, so what that is telling me is anything larger than 1.645 is going to be in my rejection region. Since it's a right tail test, we're shading into the right. Okay, so let's go ahead and see what other information I have. So we know that P is 0.25, which means that Q is 0.75. We'll perform our check in a second. We have 125 adults, so N is 125. We have 32% of them said that they did use a cell phone, so that is giving me my P hat. And my alpha level is 0.05. Okay, so let's go ahead and do our check first. Okay, so for our check, we're going to be multiplying N and P and N and Q. So N times P is 0.25 times 125. And that is going to give me 31.25. So that's bigger than 5. So that's good. All right, now N times Q is 0.75. Might seem a little silly to check this one since we already knew that 0.25 worked. This one's definitely going to work because this is a higher percentage. But I like to write everything down. So both of those check out. Yay. All right, so now let's go ahead and plug into our formula to get our Z. All right, so here we go. Z, ooh, he's a little wiggly. He's dancing. Equals P hat minus P. All right. Okay, so let's plug in. We have 0.32 square root of 0.25 times 0.75 divided by 125. I'm really trying to write nicely. Okay, so what are we getting? 1.81. Okay, so let's see. Is this in the rejection region? It is. Look, 1.81. All right, so that means we get to reject. Woo! Yay! All right, come on. I don't think my pen's had all its coffee either. Okay, so let me write my sentence. Okay. Okay, so there is enough evidence at the 5% significance level to support the claim that more than 25% of US adults have used a cellular phone to access the internet. Okay. All right, let's do another one. Okay. So for this one, we have a research center is claiming that 25% of college graduates think a college degree is not worth the cost. You decide to test this claim by asking a random sample of 200 college graduates whether they think the college is not worth the cost. Of those surveyed, 21% reply yes. At an alpha level of 10%, is there enough evidence to reject the claim? All right, so let's see. Our claim in this case is P equals 0.25. So the complement to that is going to be P does not equal 0.25. Okay, so in this case, my null hypothesis is my claim, and my alternative hypothesis is not equal to 0.25. Okay, so in this case, this is going to be a two-tailed test since I have an equal sign. All right, so two-tailed test at the 10% significant level gives me a Z of plus or minus 1.645. So essentially, I've got two rejection regions here. Negative 1.645, everything to the left of that. And then everything to the right of 1.645. Okay. All right, so let's see. Okay. So first we need to perform our check. So in this case, we have N is 200. P is 0.25. Q is 0.75. We know that we had 21% reply yes. So P hat is 0.21. All right, so let's do our check first. So we're going to see that is N times P greater than or equal to 5. And we're going to do 200 times 0.25. And that is going to give me 50. And N times Q. 200 times 0.75. And that is going to give me 150. Okay, so that checks out, yay. All right, so now we can plug into our formula. So we're gonna be doing Z equals P hat minus P divided by square root P Q N. Okay, so we're getting 0.21 minus 0.25 all divided by the square root of 0.25 times 0.75 divided by 200. Okay. All right, if I plug all that into my calculator, I'm going to get a z-score of negative 1.31. Okay, so negative 1.31 is here. So am I going to reject? And the answer is no. I'm going to fail to reject. Oh, just trying to write. Okay, fail to reject. Okay, so we're going to write our sentence. Let me give myself some more room to type it. Okay, I didn't need that much. Okay. I think it's still going. All right, let's scroll back up a little bit. All right, here we go. There is not sufficient evidence to reject the claim that 25% of college grads take a college degree. It is not worth. All right, we're gonna do one more, and I'm gonna show you how to do this in the calculator. Ooh, yay. Okay. So let me just write down the steps. Okay. Okay, so in your calculator, you're going to hit the stat button, and then you're going to hit test, and then you're going to scroll down to 1 prop Z text. Okay. All right, so let's just run through this like we have been doing with all of our labeling, and then we'll type all of it into the calculator. Okay, so you still need to start by writing your claim. So a research center claims that 30% of US adults have not purchased a certain brand because they found the advertisements distasteful. Okay, so in this case, we are going to say P is equal to 0.30. So this is my claim. So the complement of that is going to be P is not equal to 0.30. My null hypothesis is my claim. and my alternative. All right, so let's do our check. We have 250 adults. Okay, so if P is 0.30, that means Q is 0.70. So let's do our check. 0.3 times 250 is going to give me 75. And 0.7 times 250 is going to give me 175. Okay, so that works out. So fantastic. Okay, so now I'm going to label the rest of my information based on how it's going to look when you type it in the calculator. Okay, so for the calculator, you're going to have P naught, and that's going to equal 0.30. So it's pretty much like what you're testing with your claim. For X, you are going to take the percentage that you found from your survey. So in this case, 0.36. And you're going to multiply that with your total number. So 250. And you can just type that straight in. You don't actually have to do the math before you put that in where X is. Your N is obviously going to be 250 in this case. And your yeah, okay, so we have all the information. All right, so let me grab my calculator. Okay, so in this case, you're gonna hit stat, you're gonna go over to test, and then you're gonna go down to one prop Z test. Okay, so we're gonna type in P naught as 0.3. Our X value is gonna be 0.36 times our 250. Our N is 250. And then you'll notice at the bottom, the where it says prop, there are 3 options. So you are going to select the one that matches your alternative hypothesis. So in this case, it's the first one, the not equal to P naught. And if you were doing a right or a left-tailed test, you would select the appropriate one. All right, and then you're gonna, once you have everything typed in, you're gonna hit calculate. And we want to look at the p-value, okay? So in this case, our p-value is 0.0384. So from the test, we got a p-value . 0.0384. Okay, so what we need to do is we need to check, is the p-value greater than or less than alpha? So in this case, our p-value is less than our alpha, because alpha was 0.1. So in this case, we are going to reject. Okay, so let's write our sentence. There is enough evidence that the 10% significance level to reject the claim that 30% of adults have not purchased a brand because the ads are distasteful. All right.